One of the things I added to my course platform recently was this ability for me to go in as an admin and search over all my videos doing a vector search / vector embedding type of approach. So if you don't know, my course platform is built on top of Postgres, and when you're using Postgres, there's actually an extension you can install called PGVector. And this is something that I set up. I had to create a whole new Postgres database because on Railway you can't upgrade databases. So I had to kind of migrate all the old data from the old database, put it in this new database as a new extension, and now I can basically get this feature deployed out. But the idea with vector searching and vector embedding is when you have a bunch of text. So if you take a huge transcript from a video and you chunk it up and you make little vectors for all the different segments of that video, later on, if you were to ask, okay, like what video did Cody talk about Postgres? It will then find you the exact segment. And if you have timestamps associated with that segment, it could also tell you where in the video that you could potentially do that quick lookup. So I do want to kind of diagram out how this kind of works at a high level so you guys understand it. So first of all, when I upload a video, so I'll just put a user here, this is me. When I upload a new video to my course platform, it goes to my API, and then my API stores that in an R2 bucket. I am just going to use a S3 icon, but this is my R2 bucket, and I basically store the images directly to the bucket. This is basically doing a pre-signed upload to the bucket. And then later on in the API, I can then kick off a process to create the transcript. So first of all, I'll say one, upload video, 2, create transcript. Technically, there's like a pre-signed post API endpoint I hit first, but I'm just going to ignore that. And the create transcript process, how this kind of works is I fetch down the video, and then I extract the MP3, okay? Because if you're using OpenAI Whisper, which is another model that you have access to, it needs the whole MP3 file. So I'll pass the MP3 file to Whisper. And in this case, I'll get like an OpenAI icon over here. And we can say Whisper 1. And then we'll pass that to Whisper 1. And eventually we get back the transcripts, which I do store in a Postgres database. So let's just go ahead and put Postgres here, Postgres DB. And then I'll store those transcripts over here. So, so here I'll say create transcripts, and then over here I'll store them. Now, typically the transcripts that come back from OpenAI do have timestamps associated with them. I'm not actually storing the timestamps or doing anything with that, but if I did, it could make the lookups a little bit more better. So you could see that I have a video here, and you can look through here to see exactly what I talk about. And that is basically what we store into Postgres. Okay, so this is the setup for getting the transcripts. Now I'm going to talk about the actual vector embedding in the vector searching. So once I have the transcripts, what I do is I basically get them. So get the transcripts. And then I have an API endpoint that basically creates all of the transcripts into chunks. So just chunk into 500 tokens. And now that we have a bunch of chunks, what we can do is we can call another OpenAI model, which I'll just go ahead and grab this text embeddings small 3 over here. And we pass every chunk to OpenAI, and OpenAI is going to give us back, and that'll give us back like a vector with a bunch of numbers in it, right? I do believe, depending on the size of the model and the dimensions that you have set. Okay, so we get the vector, and then we can store that into Postgres. Postgres has that PGVector extension, and I'll just go ahead and say step 8 will be store vector with segment. Okay, and so now there's an association between the vector and the segment. So now that leads us to the third functionality of how do you do vector searching. So later on, if I come to the UI and I'm like, hey, I want to search my database for certain vectors, what I end up doing is I will type into an input box, and I'll say like, type in prompt. And that is going to, again, take my little prompt asking about like, where did I talk about a certain model, or where did I talk about vector embeddings or something. That still gets sent to the text embedding 3 model. And then I get back a vector. Okay, so this is a different vector. This is a vector that represents my prompt, and this is the vector that represents the segment that was talked about in the video. And there could be, hundreds of these depending on how long the video is. So once we have that vector for searching over our database, we can actually just use that Postgres extension, and that's going to go through all the segments that I have and find the one that's most relevant based on some type of scoring, and then return me a list of like the top 10. So that's why if you go back to the UI, when I search like database and click search, we get very little matches because none of these actually talk about databases. But if I talk about Automaker last night, Automaker application, let's just search that, we will get a 48% match on this video where I guess I talked about Automaker at some point. So that is a high level overview. And I would say that if you can understand how to diagram out stuff like this, you are in a better position to do agentic coding, because often when you're prompting an LLM, the more keywords and the more technical knowledge you have, for example, like if you know about this PGVector extension, if you know about how to chunk up certain things when you're building out a vector search type of system. The cool thing about AI is that you can actually take a screenshot of this and you can actually paste it in to Opus 4.5 and it can analyze your screenshot and try to create exactly what you drew. I will say, if you want any more tips and tricks about agentic coding and how to interact with these LLMs like Opus 4.5, go check out agenticjumpstart.com. This is my course. I teach you how to do Claude Code, how to use Cursor, how to do agentic coding, and it's going to make you much more efficient and faster developer. So go check that out. But going back to the actual implementation, let's kind of check out some of this code to see how it works. So when you are trying to create the embeddings, the way you do it is you basically just import this OpenAI model and you say .embeddings and you say .create. And you'll see here that you can basically just pass it some text. In our case, this could be the text from the actual video, like the segments that we chunked up, or it could be the text from the prompt. It doesn't really matter. You're going to get back that array, that vector that I talked about. So if I go back to the code where this is actually used, for example, this is the vectorized segment use case. So this is when I click the button, it goes through and it actually chunks up the video. Read through this real quick to make sure we understand the code, because that's also very important when it comes to agentic coding. You do need to understand the code. So I get the transcript and I chunk it up. Okay, and then for every chunk, I create an embedding from it. And then for all these embeddings, I push to an array. And then finally, I will create, inside my database, I insert all of these transcript chunks. So let's go and look at the schema. There is a vector data type that you can kind of set up. And we're going to go down to see where this is used. Okay, so transcript chunks, this is where I actually associate that chunk. We have a chunk ID, or sorry, chunk index. We know what video that was related to. We know what the text was for that chunk. And then we actually have the embedding stored here. This is the vector embedding, and this is what we use later on to do a lookup to figure out where, what prompt is most relevant to what we're stored in. Okay, and then that's kind of how we store the vector embeddings. But how do you actually do the search? Well, again, it's just you take that prompt, you convert it to a vector, and then there's a method to basically look up or do a search based on relevance. Later, when we need to search over all the videos based on that vector, what we could do is do a SQL query that kind of looks like this. The main thing I want to point out here is this weird little less than equals to greater than sign. This is built into PGVector directly, so this is like a cosine distance operator. So basically it takes those two vectors, it does like a comparison between them to figure out how close they are in relevancy. And then you will get back a list ordered with the most relevant to the least relevant. And you have to have the PGVector extension installed to be able to do that type of operator. So overall, that's kind of how it all works out in code. And I know there's some stuff I kind of didn't talk about in the code. I think I talked about the most important key pieces of how do these vectors get created from the OpenAI SDK? How do we store them inside of Postgres? And then also, how do we then later on search to find relevant segments based on the vector prompt that was sent in. That's all I want to kind of talk about in this video. Hope you guys enjoy this high-level overview of how I set this up in my project. Granted, all of this was literally one prompt to Opus 4.5, and it basically all worked the first try. But I do think it is good to understand how this stuff works, because when you're prompting, having specific knowledge of how an implementation might work can make your results that much better. And I don't think you're going to be able to one-shot results like this unless you know the right things to kind of ask. Go check out agenticjumpstart.com if you want an overview of how I do my agentic workflows when building out my various web applications. Have a good day and happy coding.